Hi guys, I've long time didn't make any videos, so today I'll make one. So today we will continue our I'll continue to talk about trigonometry. So first we'll just introduce the 6 general trigonometric identities, which are, so first we know that cosine, cosine and sine, right? This is pretty well. So let's introduce it by setting cosine as x and setting sine as y. Then, what is secant? Secant theta is basically just equal to 1 over x. Okay? And this stands for cosecant. Cosecant is equal to 1 over y. And then we know the tangent. Well, the tangent is one of the very original trigonometric equation, no trigonometric identity, but what's the exact value of it? Like, it's not given by a right triangle, but let's say it's just given a unit circle. Then tangent is basically y over x. And cot, which stands for cotangent, is equal to x over y. Okay, so basically you just memorize it by, if this is a co after a secant, then sine is gonna be at the top, and if it's co before a tangent, then cos is gonna be at the top because there's a cosine, right? That's how to just basically memorize. So let's say if given cosine of given that cosine of 2t, no, actually not. So let's say that if 2 times cosine t is equal to root 3, and t is limited in, and then t is less than 0 is less than pi over 2. Okay, let's see if it's like this. Then the only way, so then when you find all the trigonometric identities, representations, okay, so basically we know that we get that t is equal to, so cosine of t is equal to root 3 over 2. I have to close something, sorry. Just equal to root 3 over 2, right? So it must be less than 90 degrees, which is strictly in the interval of between 0 and pi over 2, right? Then this is only gonna be root 3 over 2, comma 1/2, which by the unit circle is basically just pi over 6. Okay. This is basically our answer. So the basic cosine of t is equal to root 3 over 2, and sine t is equal to 1/2, and secant of t, we know secant, then the cosine is going to be at the top, and this 1 over cosine, then this is basically just 2 over root 3 over 3. And cosecant, but it's basically the inverse, right? So multiply by 2, so basically it's the inverse, which is 3 over 2 root 3 times 2 root 3 times 2 root 3, just root 3 over 2. Okay, that's the value of cosecant. And how about tangent? Tangent is equal to sine over cosine, which is 1/2 over root 3 over 2, 1/2 times 2 over root 3, which is 1 over root 3, root 3 over 3. Right? This is basically root 3 over 3, and cotangent is basically equal to root 3 because this is going to be the inverse of this, which is 3 over root 3, and we rationalize and we get root 3. Okay? So that's the very basic one. So now, but then we'll kind of get deep into proof stuff. So this is basically just verifying trig identities. Let's look at a challenging problem. Let's say cosecant theta over 1 plus cotangent theta square theta is equal to sine theta. Okay, so basically what asking me this is they know that this is true. Okay, they know this is true, but how are you gonna prove this? You have to prove this through steps. So basically we just need to prove this is sine theta, and that's all. That's all what we want to prove. So cosecant is equal to 1 over sine. 1 over sine times 1 over 1 plus cotangent theta. And then we know that this is basically just equal to cosecant theta. Cosecant squares theta, right? It's basically just equal to cosecant square theta. So cosecant square theta is basically just equal to 1 over sine. One over sine square theta, right? So we get and we divide 1 by 1 over sine square theta is basically equal to 1 times sine square theta, which is sine theta times sine square theta over 1. We cancel out, so we get this is basically just, if this is 1, then this is sine theta. And this is how we're gonna prove this, basically. Okay. So basically, how can we find stuff like 1 plus cotangent square theta? This is basically just from the Pythagorean theorem. These are just fundamental stuff. So sine square theta plus cosine square theta is equal to 1, because 1 squared is 1. This is just Pythagorean theorem. Then this is provable. So let's say if we have a negative root 2 over 2, no, negative root 3 over 2, negative 1/2. You square this, you get 3/4, and you square this, and you get 1/4, and you plus, and you get 1. And there's also others. So cosecant is equal to 1 plus tangent square theta. Don't forget square when we write these stuff. And also, we know that 1 plus cotangent is equal to cosecant square theta. And this is all provable, right? Because you can just input values and you just prove it, and you will just get the same solutions. And this is really important to verify stuff like identities, because you often have to use this kind of stuff So let's look at a really challenging one, okay? So let's say 4 cosine, let's just look at some problem. 4 cosine theta square theta plus 4 times sin square theta is equal to 4. So basically, you just want to prove that this is equal to 4. This is pretty easy, actually. It looks pretty cocky, but it's actually pretty easy. Basically, use a distributive formula, then you get this is basically just equal to 4 times cos square theta plus sine square theta. And this is equal to 1, so 4 times 1 is equal to 4. And this is really easy to prove. So let's see if we can prove a really kind of complicated one. I mean, say we have something like 1 over cosecant theta plus 1 plus 1 over cosecant theta minus 1 is equal to 2 times secant theta times tangent theta. So we just want to prove that this is equal to this, okay? So we can actually simplify this even more. So this is basically just equal to 2 times 1 over cosine times sine theta over cosine theta. And this is pretty simple. Basically just 2 times sine theta over cosine square theta. And then we just want to prove this. So this looks like pretty hard, right? But then it's actually not. So first you want to take these out, and then so you want to turn the denominator as cos theta has 1 plus 1 times cos theta minus 1. This is basically just equal to cosecant square theta minus 1. And we use a Pythagorean identity, and we get that this is basically just equal to tangent square theta. So basically, it's just cosecant theta plus 1 plus cosecant theta minus 1 over tangent square theta. Basically, it's basically just 2 times cosecant theta over tangent square theta. Looks like we're getting even more close. We simplify this equal into 2 times. Okay, so basically this is just 2 over sine theta times. Okay, so the first one is simplify this, and tangent basically equal to sin. In this case, it's sin square theta over cosine square theta, right? Divide this and you multiply this by. Wait, let me erase something. You divide this by tangent square theta. Okay. So for here, you get cosecant is 2 over sine theta, and this is basically just sine square theta over cosine square theta. You divide by this means you multiply, right? Yeah, I think I didn't make any mistake. So basically, this is just 2 times secant cosecant theta over tangent square theta. Over sine theta. We divide this by sine theta square theta over cosine square theta over cosine square theta. You get, so basically C as C, Wait, actually, I made a stupid mistake. So basically, just made a lot of stuff incorrect. Okay, you just made a simple mistake. So this is actually not tangent. Okay, this is cotangent, not tangent. That's why I feel like something is getting wrong. So this is basically just cotangent theta square. Don't forget a square. Okay, don't like me making some silly mistake. Then this is basically just equal to 2 times cosecant theta over cosine square over sine square, right? Theta. This is basically just 2 over sine theta times sine square theta over cosine square theta. This, you cancel this out, you get sine theta, and then this is how our proof is finished. Let's do a really challenging one, okay? Let's do a last one. So we get 1 over 1 minus cosine theta equal to cosecant square theta plus cosecant theta, wait, what? Cosecant theta cotangent theta. That looks like a pretty long thing, and we want to prove it. We want to prove that both sides are correct. This is basically what we want to prove. Okay, so we want to first convert. We want to simplify this. This is basically just 1 over sine square. 1 over sine square plus this is what 1 over sine square theta times cosine theta over sine theta. So basically, it's just 1 plus cosine theta over sine square theta. Then, what we want to find is that we want to find this. Is this equal to this? This is equal to this, but we want to prove it. So 1 over 1 minus cosine theta. This, we want to multiply this by 1 plus cosine theta. Basically, this is also 1 plus cosine theta. This looks pretty straight clear. So this is 1 plus cos theta over 1 minus cosine square theta, which is sine square theta. And this is our answer. Thank you for watching.